Okay, so what we've done so far is we've stretched our layer 2 across a layer 3 core using EVPN and L2 VNIs. Now, if you noticed, all of the traffic flows, even though we had multiple L2 and L3 in play, all of the traffic flows stayed within the same subnet. So it was all intra-subnet flows. If you recall, 172.16.10.101 was pinging 10.102, or 20.101 was pinging 20.102 or 20.103. Okay, so always staying within the same subnet. Now we're going to move on and using some additional EVPN functionality called IRB. So this is integrated routing and bridging. So far we've been doing the B, we've been doing bridging. Now we're going to do some routing. Okay, so I've had to adapt the network to accommodate this, and what I've done is I've taken off on the client side, I've taken off the VLAN 20 interface so that all of the traffic, the customer side traffic, will be sourced from 172.16.10.101 only, and then our device here, this VTemp, will do the routing for us. So what we will be able to do is ping from this device over to this device, okay, so in the same subnet, but also across to 20.102, not just 10.102 but 20.102 as well, because we're routing between them. Okay, IRB comes in two flavors. It comes in asymmetrical and symmetrical. First of all, we're going to do asymmetrical, then we're going to move on to symmetrical. The other thing that I've done here is, because we need routing, I've added a layer 3 interface on -1. So this is going to be the gateway for this VLAN 172.16.10/24 subnet. I'm going to add that interface on there, and that's going to be a distributed Anycast gateway. So what we will have is the same IP address and MAC address configured on this VTemp and this VTemp for the 172.16.10/24 network, and then all three VTemps will be configured as the gateway 172.16.20.254, 254 and 254 for that subnet. And the reason for that, for this distributed gateway, is so that you're using the same IP address and the same MAC address for the default gateway, so that clients can move between physical VTemps and still have the same entries in their table. If you're going to do any kind of like VM mobility type stuff, so moving between physical hosts and physical VTemps. Right, so let's get on with this configuration. Okay, to reiterate, this is going to be asymmetrical IRB to start with. One of the tenets of that is that you have to have all of the destination layer 3 subnets configured local. So the VNIs and the subnets and the VLANs all need to be configured that the VTemp will possibly route to, okay, because it does all of the routing locally. Okay, first of all, I'll show you what I've done then on client 1. So I've taken off that VLAN 20 interface. So now we've just got an interface in VLAN 10. And because this device needs to know how to get to, sorry, not to route to, but how to send traffic to other subnets, I've added in a route. So if we do a route, you can see that I've got a destination of 172.16.20, of course, here, going via this address, and that's going to be the layer 3 address that I configure on the VTemp. It's going to be a distributed gateway with Aruba. That's called an active gateway. Okay, right. Okay, so here I am on 6300-1. First of all, I need to configure a VRF. Okay, so I'll configure VRF A, and we need a route distinguisher, and we need route targets both. Okay, one, and there's a special designation of EVPN there. Now, just to reiterate, okay, so kind of recap, when we initial traffic flows, they were intra-subnet. What we're moving on to with IRB is inter-subnet, but it's within the same VRF still. Okay, so we're moving between subnets but within the same VRF. So VLAN 10 and VLAN 20, they're going to be the associated subnets are going to be in the same VRF here. Now let's create the layer 3 interfaces. So that's VLAN 10. I give that an IP address 17.10.1/24. Of course not. First of all, I need to associate it with a VRF. There we go. 8. now the IP address, sorry, 172.16.10.1/24, plus we want to do the active gateway. So the active gateway, the way that we configure it, we've got an IP address, so it's going to be 16.10.254, and a MAC address, which is in this format. Is that 5? I'll go AA. I think that should do us. Show run. Where is it? There we are. Okay, so that's our VLAN 10. So that's that interface here, and I need one for 20 as well because this is asymmetrical. So we go interface VLAN 20 VRF attach. Remember, it's the same VRF A IP address 172.16.1/24, and that active gateway is going to be IP is 172.16.20.254, and the MAC address 45, and let's go BB. Okay, I'll save that. Same again on 2. So this is quite repetitive stuff, but VRF A, no, come on, conf VRF A, give it a different to target both. EVPN, VLAN, and it's 10. VRF attach A, IP address 172.16.10.2/24. Let's copy that. So because the active gateway is going to be the same. Oh, I'll go MAC anyway. Doesn't do it in a single line. Fine. So it's active gateway IP 172.10.254. So add that one in. Okay. Show run. Okay. And conf is in VLAN 20 VRF attach A 16.20.2/24 active gateway 16.20.254, and the MAC is 1, 2, 3, 4, 5. Okay, save that. And finally, now as I mentioned with 3, you need to have all of the destinations if you're using asymmetrical. So even though we don't have a client on there, we do need to configure a VLAN 10 on 3 if we want to route to that. So we go on to 3. So essentially that diagram, it should have a purple line to be honest, but I'll just go ahead with this. So it's VRF A EVP. Okay, no. Wrong one. Okay, both. Sorry. EVPN. So we do need a VLAN 10. Int VLAN 10. VRF attach. A IP address 16.10.3/24. I'll add in the active gateway as well. So to 16.10. What's it? 254 MAC address. VLAN 20. Attach a IP address. So 216.20.3/24. Active gateway. Okay. The only thing is, because we didn't, Yeah, it's down, right. So conf int, what's it? Let's add that on there. VLAN trunk, active gateway running there on both VLANs. Okay, let's go on to client 1, see if we can ping locally. Client 1. Okay, so now I'm on client 1. Let's ping 172.16.10.254. Okay, so I can ping the active gateway. I can still ping the local, this address as well. So that address and the active gateway are available. Can I ping onto this address though as well? So that's local. Yeah, I can. Okay, so I can go off subnet. Like I don't have an address tool that is actually coming in here and it's routing on that. This device is routing between these two subnets. Okay, but that's local side. So we're not doing that off to, you know, across the VXLAN network. So let's have a look at the tables then. Show BGP L2 VPN EVPN. What we've got is we've got, no, it's somewhat different actually, because an RT2 can carry a MAC address and an IP address. Okay, so originally when we were doing just the L2 VNI stuff with no IRB, we just had those MAC addresses, if you recall. And now what we've got is we've got ones that are a combination of a MAC address and an IP address. Okay, so we can see 101 there, so that's the full client, right? So, but it's still an RT2. So RT2s can carry MAC address. That's totally valid if you're just doing bridging, that it would be a MAC address. But you can also have the layer 3 address as well, which is what we see here. And we see the locally injected one, so that's the active gateway in there, right? So previously, if you recall, what we were doing was just looking at the MAC address table like this. Okay, now what we're doing is we're looking at the ARP table. Now the ARP table, of course, is going to be VRF specific. There you go. Okay, right, so let's have a look at that. Right, we've got the IP address and resolved to the MAC address on VLAN 10. Okay, because now we're doing layer 3. But what we want to do is we don't just want to be local here. We want to ping across to, well, let's start with the easier one. So let's ping 172.16.10.102. So this is still okay, fine. So that's still intra-subnet. Now let's go off subnet. So we're pinging to 172.16.20.102. Okay, and that works as well. Okay, so what we've got there is we've got traffic coming from 172.16.10.101 is hitting the local default gateway, this 254, is being routed to the destination encapsulated in the VNI for the destination subnet and sent across to our peer. So we're sending the traffic encapsulated in VNI, so that's 1020 is being sent to 172.16.20.102. So that's asymmetrical IRB happening there. Okay, so we're routing across, and the way that this happens, let's have a look at that ARP table. Yeah, okay, so now in the ARP table you can see you've got a local entry and we've got a remote entry. Okay, so this device carries the ARP entries for this destination, really, and this is at the heart of what asymmetrical IRB is doing. Now, if you recall, you know, I won't go deep into the theory for this video because it's more about the config, but essentially what we have is, because we have the layer 3 and the layer 2 configured, so we have show run, what is it, VLAN 10, and we've got VLAN 20 configured locally. When we receive a packet, so that if you think about this, the destination packet for that's received here, we're pinging 172.16.20.102, right? So the source is 10.101, destination is 20.102. That hits this because it's going to come off of here, going to the default gateway, which is this gateway, which I've configured here. So we'll get an ARP for that, which is this MAC address, right? That's going to hit this vtemp, and then we need to do a lookup for the 172.16.20 network. Now let's have a look at our routing table. Remember, it's in a VRF. And the thing is, the routing table, I'll bring that to the top. Okay, the routing table, because it's locally configured, it's a local lookup. You know, it's directly connected. You can see the C. So it's the origin code is directly connected. Okay, so we know about that destination subnet. And because we know about the destination subnet, what we do is we actually ARP for that destination. If we don't have an entry, we ARP for that destination and then pick that up because we already know about that layer 2, that destination layer 2. So we carry, -1 carries an entry for that. And what that means is that we know which VNI to place the traffic in before we send it. Okay, so the ingress VTemp, so -1 here, is doing all the work essentially, right? This is why it's called asymmetrical, because it does more lookups than the egress VTemp. The ingress VTemp already knows about the destination subnet and it knows about the destination L2. It knows how to send it because it's got an ARP entry for it. It sends it to the egress VTemp, and the egress VTemp just needs to do a MAC table lookup to find out which port to send it out on. Okay, so that's why it's asymmetrical, because the ingress VTemp, it does much more work. Now, the downside of this is that we have to carry all of the ARP entries that we need to route to. You know, so you've got your destination subnets all connected, but also we need the entries for this. We need to be able to resolve the IP and the hardware address. Okay, so that's why asymmetrical doesn't scale as well as symmetrical, which we'll move on to. Okay, but there you can see, if we look at, let's go back to those tables. You've got the BGP L2 EVPN table. You've got the full entries for that. This is the local, and then where's our remote one? Yeah, so what we receive is we receive an update for our destination. And before we finish off, I realized I haven't finished part of the configuration down on 3 here, which really kind of emphasizes what you need to do for asymmetrical. So I did add in the layer 3 interfaces, but there's more that I need to do. So if I try to ping from 172.16.20.103 over to 172.16.10.101, that's not going to work. Now the reason is because I haven't completed the configuration. I still need to add in EVPN, I need to add that VLAN 10. You know, the whole configuration is required for the destination subnets that you're going to go to. So route distinguisher, what was it? Auto, sorry. Route distinguisher, auto, route targets, both auto. And what was the other thing? If I go, I'll show you the VXLAN, so I don't have that binding between the VNI, so I don't have the VNI at the moment, right? I need to add that in, so VNI 1010 and that binding to VLAN 10, I need that as well. So let's add that in. Interface VXLAN 1, VNI 1010, VLAN 10. Okay, and straight away it starts to work. Okay. Right, so that full configuration then on, this is -3. So we've got the VRF, fine. I've had to add in this because I had that before for the EVPN, but I've had to add in the destination VLAN of 10, the ones that I want to route to. I've added that in as well. And where was the other one? Okay, the VXLAN interface, okay, that binding there. And now it's all working. So that's the configuration on -3, and that's asymmetrical. Okay, so we need all the destinations. It doesn't scale as well because we're carrying the information, we're carrying the ARP entries. What was it, VRF-A? We're carrying the ARP entries for our destinations. Okay, but there is a scale, so the tables are going to fill, and then we're going to burn up these finite resources on the switch. But there is a way of having IRB where you don't have to carry information about the destination layer 2 networks. You don't need that ARP cache entry, okay? And that's with symmetrical that we're going to move on to. Okay, so the final stage of this EVPN-VXLAN config marathon is that we're going to configure symmetrical IRB. Now, this is the one which is more scalable, and that's because we don't need to configure all of the possible destination L2 information. You know, you don't need to have EVPN configured for, in this example, we don't need to configure an L3 interface in VLAN 20. If we want to route to VLAN 20, we don't have to have VNI 1020 on -1. We just have the local, so the VLAN, the L3 and the VNI that we're going to source traffic from. Okay, we don't need to have all of the possible destinations, and that's how it scales. Okay, so there's more nuances to this. I'm not going to go deep into the details. Like I said, this is more just showing you the configuration. The explainer stuff is to come later, right? What we need to do is we do need to configure some extra parts of this, because there is some extra complexity in symmetrical, and that what that's all to do with is to ensure that you don't need to configure all of those destination subnets and those destination MAC addresses local to the box, right? So the extra things that we need, so this is a new route type, so it's a route type 5. We need to have a virtual MAC that we can send to, and we need to configure what's called an L3 VNI, which is shared between all the vtemps, right? So the L3 VNI also needs to be configured. So there's extra points, and all of the things that we're configuring, which you'll see me configure, is just so that we don't have to. It's because we can't do that. Remember, with asymmetrical, everything was locally connected because you had the destination subnets, you had the ARP cache was populated with the destination MAC addresses. We don't have that with symmetrical, and that means that we're not burning up those finite resources, but it means that we need some way of sending the traffic. So if we're going to send traffic to our remote vtemps, when we did it with asymmetrical, we were able to route onto that VNI locally, and then we sent the traffic in that VNI. What if we don't know about the destination VNI, like that, because we haven't routed onto it? What we do is we route onto this shared VNI. It's called the L3 VNI, which I will configure. Okay, and the L3 VNI is configured per VRF. I'll show you all of this. Right, so I need to tidy up some of these configs to get and add some new things like the virtual MAC and some BGP configuration to get this working. So let's get on with that. Okay, for symmetrical, we can strip off those destination subnets and VLANs that we don't need. So we can take off that. So I can take off no interface VLAN 20. Okay, I don't need that. Fine, don't worry about that. No VLAN, I can take off VLAN 20 entirely. I don't need that on my device. Let's have a look what else we can take it off. Okay, so the EVPN has updated itself because I've taken off VLAN 20. What else? Okay, we don't have VLAN 20 live anymore. Good. Oh, and I can also update that so it's interface VXLAN 1. Bring this, so I'm on interface VXLAN 1, and I'm going to do a no VNI 1020. Okay, so we're going to use symmetrical IRB rather than carry all of this information. Right, and the steps that we need are, I need to configure this. So this is the MAC address, because we don't have a destination MAC address when we're sending across the core. We need something for the inner MAC address to send to, right? This is deep into the information about symmetrical IRB, which I will go into at a later date. But essentially what we do is we have a virtual MAC like this, and we add a virtual MAC on here. It's the same format as before. I'll call it 1, 1. I think that should work. Okay, good. And the other thing that we need to do is we need to go onto BGP, and because we need to advertise our subnets. Because they're not directly connected anymore, we do actually have to advertise them. And the way that we advertise them is with a new route type. It's a route type 5. So we need to be able to inject those into BGP. So we do an address family. What is it? No, it's in the VRF first. This is all customer side. So it's VRF A, it's address family, and we've just got IPv4 unicast. And what shall I do? I'll do a network 172.16.10.0. Okay, just do a /24 there. Save that. Show run. Okay, so this needs to be added in. And that's because we're advertising the routes via BGP now to our peers, because all of the peers are not configured with the directly connected, okay? You do actually have to advertise that. And the other really important thing that we need to configure is that shared VNI. So this is the VNI that is aligned with the VRF, and it's the VNI. This is how we encapsulate the traffic when we send it across the core, when we want the egress, when we want the remote VTemp to do the final routing for us. And that's what we're doing with Symmetrical. Okay, so I know there's a lot here. This is complicated, okay? But the way that we do it is we do a VNI and we give it a completely different number. So I normally use 5,000 for this, right? And I always forget which one we can do first. I think you add it to a VRF, right? We add it to a VRF and then we call it a routing VNI, okay? So that's the one that we will route onto. Let's have a look at that configuration. There you see. So we don't have the VNIs that we're routing to. If we go and look at our BGP L2 EVPN table, now we have in it, we have a different type of route type. So this is how we are, because we're not just advertising standard BGP IPv4 unicast prefixes. This is all within EVPN. What we have is we have a new route type for advertising prefixes. Because they're not all directly connected, we advertise them across this L3 VNI. Okay, so you can see that entry there. That's our local subnet. That's this subnet here being advertised in the L3 VNI. So that's the routing VNI, and you can see we're injecting it locally. Okay, so that is -1. Save that. Let's jump over to -2. Now -2 I'm going to leave more as a asymmetrical setup, and it's going to have clients in those two subnets. Okay, so I'm going to say, like, physically it does have those two subnets, so I want to keep those, but I need to add in those extras as well so that Symmetrical will work for remote routing to this. So what were those points? Virtual MAC, to add that in. I can't remember how I did. What was the format there? Not that it matters. Okay, 0. Okay, not that it matters at all, but you know, can't even remember what I've been doing as I go. Right. Now the other point is we need those router BGP. So it's VRF-A, unicast, and let's put in 2.16.10.0/24. We'll do 20 as well. And then interface VXLAN 1. It's VNI 5. So it's shared, okay? It's the VNI needs to be shared, so you need the same number. VRF-A routing, okay? So, and what that means for the receiving VTemp is that the traffic that it receives on that VNI, it knows that it needs to do a layer 3 lookup for it, because it still needs to be routed, okay? I think we're good there. Show BGP L3 EVPN. So we should have some type for, yeah, so we've got some, these are that's the local injected. No, sorry, this is the one that's learnt remotely, because third.tech.10 is learnt remotely, and these are the locally injected subnets there, the RT5s. And then finally, we need to go down to 3. Now we need to do more on 3, just like with 1, because 3 is only going to be in one of the subnets. So I'm going to take off, so it's no interface VLAN 10, no VLAN 10. We don't need that VNI anymore. While we're in the VXLAN, we might as well add in the routing VNI. That's good. Oh, we need the BGP, don't we? BGP, and it is VRF-A, address family IPv4 unicast network 172.16.20.0/24. And the final thing, which I must not forget, which is really easy to forget, is that virtual MAC 303. Okay, I think that's it. show BGP L2 EVPN. Should see some entries on dash. So now I should see some entries on dash 1 from 3. Yeah, there we are. Okay. Okay, so if we look at 3, what I've done is I've stripped that down. EVPN now doesn't have VLAN 10 on there. We've just got VLAN 20. You've got, yeah, the VNI, the shared VNI there, and the injection of the IP prefixes because they're not directly connected. Okay. Right. So let's see if this actually works. Right. I'm on client 1. Let's do a ping 172.16.10.254. So that's the local. Yep. Okay. Local gateway. Fine. Right, so let's try to ping within subnet. We'll go over to 102. 102. Okay, that's working. Okay, fine. Now let's do something a bit more interesting. Okay, and that's working as well. So, final one. Fingers crossed. Yeah, okay, so they're all working. Right, brilliant. So it does work. Now, let's have a look then. So the tables are a bit different because... Oh, show ARP VRFA. So we don't have the remote ARP entries, okay? We don't know about the L2 of the remote vtemps. That's how this makes this much more scalable. So we can route to them, and the way that we route to them is we use our routing table. So we've got, if we go VRFA, you can see we have updates for that via the next hop of .2, okay? So when we want to get to 102, we're routing to this. Look a bit deeper at that. So what was it? 172.16.20.0 VRFA. You can see that it's not directly connected. It's learnt via BGP EVPN. The next hop's going to be .2, and the encapsulation data. So if you've got traffic to send to this destination, you encapsulate it with VXLAN, and here's the details that you need to add in it. That's the VNI. So that's the L3 VNI. So this device here, the packet walkthrough is that this sends a packet to this destination, 172.20.102. It sends it to its default gateway. The default gateway, this vtemp, knows that it's sent directly to it, so it needs to do an L3 lookup. It looks up in its routing table, this here, for that destination subnet. It's got it, and that is known via EVPN. It's not directly connected, as I keep saying, you know. So if you want to send to it, you need to send to 192.168.0.2, so this device here, and the traffic should be encapsulated with the VNI of 5,000. And then the receiving end, so if we go on to 102, we look at the routing table there via, so what is it, 172.16.20.0 VRFA. Now that is locally connected, right? So that will then do a lookup in its local table for VLAN 20. So it needs, at this stage, it needs to ARP for it. VRFA. You'll see the destination of 102 there. There's the MAC address to be added to it, and there's the physical port that it needs to send it out to. So the vtemps only carry the L2 information. They're only burning the L2 cache, you know, the finite resources for the destinations that are local to them, not for all the remote ones, right? Because it's using the L3 VNI for the routing, and it's learning about the destinations that it needs to route to via the BGP updates, the RT5s. I know that there's a lot to this. I will be breaking all of this down into dedicated videos in the future, okay? So it's the RT5 fives that we're using for those destinations. Now, and this, if we go back to 1, this highlights a problem. Now, the problem is, if you notice, so if I want to send traffic to, let's send the traffic first of all so you can see that it works. So we'll do this client 1, we'll go from here to here, okay? So this ping 172.16, this is just to finish off, right? So this is like an extra to it. So we can ping that, fine. Now, if I do a destination, this being the default gateway, where am I routing this to? If I go to 172.16.20.103, oh, I keep doing that wrong, sorry, 172.16.20.103 VRFA. Okay, you can see that the next hop is .2, so we think that we have to go across here, which will then send it on, right? And the reason for that is because both of these devices, both of these VTEMs are configured with that destination subnet, but BGP is choosing one, and it doesn't necessarily know about where the client sits. The client sits down here, but the BGP best path is this one, right? So the way that we can solve this is that we can inject the RT2 for this destination, because if you look in the BGP table, show BGP EVPN, we still do, even though we're sending those RT5s, we still do have the updates. So 103, yeah, there's 103 there. So we do know in the BGP table that the next hop is .3, but we're not using that because we're using the RT5 entry in the routing table. There you go, so .2. Now what we can do is we can add in, it's at the VTEMP that advertises the routes that we do this, okay? So if we go over to, let's split this actually. I'll split that. I'll go over to 3. There's an extra piece of configuration that we can add in the EVPN. And what we do is VLAN 20 and we do redistribute host route. So we add that in. EVPN. What starts to happen is that we start to advertise the host route across the shared VNI, not just in the L2 VNI, but actually in the shared VNI. And what that means is that then we will update our routing. I'll show you the whole thing. So there you can see 103. So what we do is we start to redistribute the /32 in EVPN. We put the redistribute host route under EVPN on this device, and that will advertise it, not just the RT5, not just L2 VNI specific RT2, but actually it will start to advertise the /32 for the hosts in the shared VNI. And then when the devices receive that, when the remote VTEMPs receive that, that will mean that they inject the /32s into their table. And so now if we do a client specific lookup, so 172.16.20.103, we know that that's via .3. So it will go to the direct device. Rather than going to .2, it goes directly to .3. Okay, you can see that they're routing across the L3 VNI. Okay, so what I would need to do is I'd need to go on here to make sure that all of them are correct. I would go on to, what was it, 10 I've got here, and I'd do redistribute host route, save that, and finally on to, I'll go EVPN, redistribute host route, and 20. Okay, so then I should see more entries in the shared. You start to see more entries in the shared L3 VNI. And you can see specific /32s in the routing table. So it does start to fill the routing table with the /32s, and Aruba has a fib optimization. I haven't got time to cover that, but like if you look up Aruba fib optimization to make sure that the only the active flows are passed down to the hardware. So we keep the inactive flows, the /32. So it's like some Aruba optimization that's happened so that we don't just push and burn up lots of the routing table resources down on hardware. They just stay in memory unless they're active. Okay, so it's like we're trying to solve some inefficiencies there within the EVPN, so we redistribute the routes, but then that fills the routing table, and so we have an additional efficiency with fib optimization. But one of the things to remember is that it's the fib that's being filled with a /32, so that's got more capacity, you know, because that's in memory, rather than we're not filling our ARP cache up with entries. Okay, so we only see the ARP cache has only got the local entry because we don't carry the ARP entries with Symmetrical IRB for our remote subnets that we want to route to. Okay, so that's it for this rather large configuration focused video. Thank you very much for watching. My name is Joe Neville, and goodbye.